Welcome back. So today we're going to continue our investigation of the fundamental theorem of algebra. Today we're going to investigate the idea that you can actually go above cubics when you're solving things this way. Now, when you have something like a quartic, all that means is you have to use synthetic division multiple times to get the polynomial down to a cubic that you can solve, or to a quadratic that you can solve. So, I'm going to start just like last time. I'm going to plug that into my calculator. So x to the 4, unfortunately there's no nice way to type that in. You do have to use the caret key this time. When I say caret key, I mean that key right there. All right, that's what you have to use when you're dealing with fourth powers. Plus 2x cubed plus 6x squared plus 18x minus 27. So type it in, and I'm going to graph it. All right, and I see two zeros. Right, I see one at -3 and one at 1. And again, it's always a good idea to check to make sure that they're actually truly zeros. So -3 does turn out to be 0, and 1 does turn out to be 0. All right, so we have two zeros right now. And what I'm going to do is, because I have two that I can take out, means I can use synthetic division twice. So I'm going to start with my 1. Okay, I'm going to start by pulling that one out. 1x to the 4, 2x cubed, 6x squared, 18x minus 27. So I'm going to pull that 1 out. Bring it down, multiply. Add, multiply. Add, multiply. Add, oh, that's not what they multiply to. I apologize. Multiply by 1, add. All right, so this did turn out. I got my remainder of 0, constant of 27, x of 9, x squared of 3, and an x cubed of 1. So that means I have x cubed plus 3x squared plus 9x plus 27 left. And that's after pulling out my solution of 1. Well, I'm still wondering where this equals 0. Now, don't forget, we actually had another 0 that we had already found. Okay, from our graph, we also saw -3. So what I'm going to do is I'm going to pull that -3 out of my reduced polynomial. Okay, so the 1x cubed, 3x squared, 9x, 27. I'm now going to pull -3 out of that. I'm going to pull the second solution out of that, because then I'll have a quadratic left that I know how to solve. So I'm going to use synthetic division a second time. Pull down the 1, multiply by -3. Add, multiply by -3. Add, multiply by -3, add. All right. So now, just like I said, now notice what we have. We have a quadratic left. So x squared plus 9, because we pulled out yet another 0. All right, and because I have a quadratic now and I'm searching for zeros, now I can finally solve that, and I'll have all of my zeros. So I'm going to subtract the 9, square root both sides. That'll give me plus or minus 3, but because the 9 was negative, I'm also going to get an I there. So plus or minus 3I. So if you think about it, this time I started with a quartic function. I started with a quartic. And what were my solutions? 3 or 1, negative 3 plus or minus 3I. I have 4 solutions, just like the fundamental theorem of algebra guaranteed me to have. All right, let's try this one more time just to make sure you're feeling confident in being able to do this. So I'm going to go to my calculator, go to y equals, clear out what I've got, and I'm going to type in that function. X to the 4, again using that caret key, minus x cubed minus 14x, oh, that was not x, 14x squared plus 2x plus 24. So type it in, and I go to graph. All right, so notice here, it's crossing in 4 places, all right? It's crossing here, 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 and here. So those are my 4 solutions. However, I want you to realize that only 2 of them are crossing at nice values. Okay, the ones that aren't crossing at nice values, you don't want to use. Okay, they're not going to be helpful to us. Only focus on the nice ones. In this case, that's going to be negative 3 and positive 4. And again, let's just really quick check to make sure that that's working the way that we want it to. So, find the value at negative 3, which is 0. Find the value at 4, which is 0. So those are the 2 solutions that we're looking for, negative 3 and 4. So I have 2 solutions that I can synthetically divide out of my polynomial. So I'm going to start with a negative 3. I'm going to synthetically divide that out first. 1x to the 4 minus 1x cubed minus 14x squared plus 2x plus 24. Pull down the 1, multiply by negative 3. Add, multiply by negative 3. Add, multiply by negative 3. Add, multiply by negative 3, and add. All right. So negative 3 is one of my solutions. And what I've done is now I've made a reduced polynomial. I have a cubic left after pulling out that negative 3. So now I have an x cubed minus 4x squared minus 2x plus 8. And I'm still searching for the zeros. Well, thankfully, I actually already know one of the other zeros. Okay, I could see it on the graph. So now I'm going to pull the 4 out that I saw on the graph. So 1x cubed minus 4x squared minus 2x plus 8. Now I'm going to synthetically divide the 4 out of that to reduce it again. So pull the 1 down, multiply by 4. Add, multiply by 4. Add, multiply by 4. Add, boom. All right. So just like I said, after pulling out my solution of 4, now what I have is a quadratic. So I have x squared minus 2. And again, I'm still searching for the zeros. But this time, since what I have left is a quadratic, that means that I can actually solve this. I can add the 2 over, square root both sides. Remember, when you square root, you get a plus and a minus. So I get plus or minus square root of 2. And I want you to think where this problem started, okay? It started with something to the 4th degree. Well, the 4th degree, that meant we should be looking for 4 solutions. And that's exactly what we got. We got our 4 solutions. So again, that's the really cool thing about this fundamental theorem of algebra. Using synthetic division lets you find every zero of a polynomial. So thank you so much for joining me through this. Make sure you have all of it written down, and then come see me if you still have any questions about it.